In this video, we will be doing a shorter version on selection sort, how it works, and why it is in the order of n squared. So there's a longer version in the video right before this, which is 70, but I thought it was super long. So this is for those who are looking for short videos or short explanation because they don't have a lot of time. So for this video, we are going to be sorting from smallest to largest. So selection sort repeatedly tries to find the smallest element in the unsorted part of the array and swaps it with the first unsorted element. So what we actually have here is a function that's going to perform the selection sort. The code is already there because this code is pretty much out on the internet, and I just wanted to spend the time to explain it. So this function is used to perform selection sort on a vector, and we've passed that vector by reference. The reason why we passed it by reference is so that whatever changes that happen to the vector inside this function actually works or modifies the actual and original function itself. I'm going to minimize. In the main loop, we've defined a vector with whole numbers 5291. We displayed the content of the vector before it was sorted. We then called the method selection sort to sort it, and then displayed it again using for each loop to display the content or the sorted vector after it was sorted. So here is what we have. The original vector is 5291. That's what's happening inside the loop, inside the function. And then, so pretty much what's happening here. And then after it's been sorted, it's 1259. So let's go inside this function to explain pretty much what is going on. So you've actually noticed that this is running 3 times. So there's iteration 1, iteration 2, and iteration 3, whereas we actually have 4 numbers, not 3. So let's see what's going on. First, we got in the size of the vector, which we stored into a variable called n using the vector.size. So that's going to give us the value n, 4, because the original list is 1259 so that's a total of 4 numbers. So what we do in the outer loop, we will loop through all elements except the last one, which is already sorted because all the others are in place. And that's why selection sort runs for n-1 iterations. Okay, so that explains why we only have 1, 2, 3 iterations, and the last one is automatically going to be counted as sorted. So I is going to run from for n-1 times, which is pretty much 3 times, because we start from 0 and we end at 3, but it's less than. So it's only going to go 0, 1, 2. So n- times. Whereas j, this is j, the second loop. Now the second loop here is going to run inside the first loop. So when I is equal to 0, we're going to run another loop in. That other loop is going to be used to find the minimum element in the unsorted part of the vector. Now we see that j is kind of connected to I. It's kind of, attached or, kind of dependent on I. So when I increments, so j is always I plus 1. So in this case, j is going to start from 1, at 2, and 3. Because the condition here is less than n, not n-1, like we had with I. So what's going to happen is j is going to run n-1 minus I times for each iteration of the outer loop. So in the first loop, when I is equal to 0, j is going to run 3 times. But when I is equal to 1, j is going to run 2 times, because it's going to be 4 minus 1 minus I. So it's going to be 4 minus 1, 3 minus 1, that's going to run 2 times. And when I is equal to 2, j is going to run only 1 time. So that's n, which is 4, minus 1, 3. That's 3 minus 2 is equal to 1. So that's pretty much how this is. We'll explain later why this is in the order of n squared. Okay, so let's have a look at what's happening here. Here we assume that the current index is the minimum. So what's pretty much happening here is we're trying to find the minimum element in the unsorted part of a vector. And what we do is we update the minimum index if a smaller element is found. And then if that value of minimum index changes, then we know this value has changed here, because initially the minimum index is equal to I. It will no longer be equal to I if this was true. So here we're checking, did it change? Did the minimum index no longer equal to I? Then do a swap. And then this is just for debugging purposes. I'll put it there from the previous video, but we can actually get rid of it. But let's see what's happening. So with these numbers in iteration 1, when I is equal to 0, here is what's actually happening. I'm just going to copy some code and put it in like this. Oh, sorry, it's not really code, it's comments. So the list from index 1, yeah, is compared with 5. So the original list, the original list is this one. That's the original list, 5291. 5291. So what's happening here, because I is 0, so the list from index 1, because J starts from 1, okay, is compared with value 5. So this is the index. So 5 is sitting at index 0, 2 is sitting at index 1. It's just for me to help me remember. It's just easier. So to see if there's a smaller value, so what we're doing is we are looking, we start with this, assuming this is the smallest value, and then we search this part to see if there's a smaller value. Now here, the smallest value is 1, which sits at index 3. And later, somewhere here, so this becomes index 3, and then this no longer equals to I, and the swap happens. And so the smallest value is, so the smallest value 1 at index 3 is then swapped with 5. So the result would be 1295. So that's what happens after iteration 1. And in iteration 2, let me copy some code. Iteration 2. Here is what happens. Iteration 2, when I is equal to 1. This is what the list is like. So that's what the list was, 1295. Now here, the list from index 2, because J increments, no, sorry, this is another around. So J starts from 2, because I would be 1. When I is 1, J would be 2. So the list from index 2, from index 2 is compared with 2, with this value, to see if there's a smaller value. So what we're doing now is we're looking at these values to see if there's a smaller value. Since there isn't one, then the list remains the same, 1295. So this part never happens. Swap never happens. So here, the list is pretty much the same in the second iteration. And let's have a look at what happens in the third iteration. Let me copy some code and paste it here. Iteration 3, when I is equal to 2. So when I is equal to 2, J is 3. So the list from index 3, this one, is compared with 9, the value 9. And to see if there's a smaller value. The smallest value, 5, is 5. At index 3 is swapped with 9. So the result would be 1259. So that's pretty much it. That's how the array, that's how it works. So after iteration 3, it's 1259. Now the time complexity of selection sort is in the order of n squared in all cases, because it has 2 nested loops. So imagine you have to do something n times, and for each time you have to do another n tasks. This results in n times n tasks, which is n squared. Now, even though the inner loop, which is J, if we looked here, okay, so it kind of reduces every time because it's AI minus 1. Even though the inner loop does slightly fewer tasks each time, the total number of tasks is still n times n roughly, because n is the dominating complexity over the constant. I hope this was a shorter version, and I'll see you in the next one. Thank you.